we have now, we've done amplitude, which was our A, and we did the period, which was based on our B value, right? Because the period stretched our graph and made it wider and happened at a longer time. Or if we had a horizontal stretch that was like a half or a third, it made the period shorter than 2 pi. But the period of a basic sine or cos graph is 2 pi, right? Or 360. It repeats itself in a circle like the unit circle. So off of an equation, the amplitude was just the absolute value of A. Off of a graph, the amplitude was the distance from min to max divided by 2, correct? The period off of an equation is 2 pi divided by the B, or 360 divided by the B, or 2 pi times the horizontal stretch, or 360 times the horizontal stretch, right? Or on a graph, it was how long it took to repeat itself. Today, what we're going to look at is those as well, but we're also going to look at the C and the D. So C is your horizontal translation, and D is your vertical translation. So all the translations and transformations happening to it, and reflections, etc. So what transformation has occurred in number 1? So this is the catch. Only in trig do we say vertical displacement and horizontal phase shift. If we are in any other unit, radicals, rationals, logs, exponentials, polynomials, quadratics, which is in polynomials, I don't know, I stated it differently. If we're in any of those units, it's called a vertical translation and a horizontal translation. But in trig, it's called a vertical displacement. Three up. So when we have vertical translations or vertical stretches or reflections in the x-axis, what variable are we affecting? The y. So on our graph, let's think about it. The period is affected by squishing horizontally or stretching horizontally. So that affects x's, correct? Yes? Going to the right or to the left will move the whole graph around, which will affect our x-intercepts as well. Yeah? Let's think about it. Now, if I move it vertically up or down, does that change my amplitude? If I move it vertically up or down, does it make it a bigger amplitude or a smaller amplitude? No, it just takes my graph and it shifts it up or down. So it's not going to change my amplitude. Will it change my range? Absolutely. If my range was 0 to 3 and I'm moving it 3 up, it's going to be 3 to 6 now, right? So this graph, let's say, it's a basic sine graph. Basic sine graphs are from -1 to 1. We agree? Yeah? But I'm moving it 3 up. So where is it going to be at now? 2. Do we think so? Type in your calculator. Y equals sine x plus 3. So we get 2 to 4. What did we do last time to get our max and our min? Our minimum, we took that midline. Our midline is literally what our D value is, right? So if you look at that current graph you have, the graph is cut at half at y equals 3, is it not? If you look at the graph you have on your calculators, it's cut at y equals 3. And what's my amplitude on here? What's the amplitude on this equation? 1, correct? So if I have a midline at 3 and I'm moving up 1, what am I maxing out at? 4. And I'm moving down 1, what am I minning out at? 2. So my minimum is D minus the amplitude, and my maximum is D plus the amplitude, always. Because you're taking that middle line that's cutting the graph in half and adding amplitude and subtracting it from it. So in this case, it would be 4 minus 1, which is not 4. 3 minus 1. 3 minus 1, which is 2, or 4 or 3. Oh my God, why do I keep writing 4? Stop it. 3 plus 1, which is 4. So my range changes, yes, but the graph is no wider or is no taller or shorter. Has that only thing that changes that is my vertical stretch, which is my A value, my amplitude. Does the period of this graph change? The period is changed by what? Horizontal stretch, there isn't one. Is my domain changed? No, because the domain is XER. Do my x-intercepts change if I move the graph up? This one specifically does. I had x-intercepts. I now no longer have x-intercepts. The whole graph moved up. So if you move the graph up or down, it changes your x-intercepts because it moves the entire graph off of that, either completely off the x-axis or maybe moves it around on the x-axis. So vertical translations do, vertical displacements do change your x-intercept. And they're obviously going to change your y-intercept because they affect y's. We agree? So how could the range be obtained? By using this. So we are going to do, I'll do interval notation first. It's going to be 2 to 4. Next one I'll do set. So this one, I have a vertical displacement. Two down. What's my range going to be? What's my max? What's the midline on this graph? Midline is y equals the d value. So in this case, it's going to be y equals -2. So I take my midline, the middle line that cuts the graph in half, right? And if I add to it my amplitude, I'll get to the top. And if I subtract from it my amplitude, I get to the bottom. We agree? So in this case, my max is going to be -2 plus, what's my amplitude? 1. So this graph has a max at -1 and the min at -2 minus 1. So it's at -3. So what's my range in set notation? Y such that -3 is less than or equal to y is less than or equal to -1. Remember, you always go low to high. Knowing what we know, I want you to try 3 and 4. So this one, we have a vertical stretch. What do vertical stretches change? By a factor of 3 about the x-axis. What do vertical stretches change? What does the A stand for? What can we get from this value on our equation? Our amplitude. So what changed? Our amplitude. Right? It's normally what? 1. If it's not, it changed. So our vertical stretch obviously changed our amplitude because it pulls the graph to be like wider vertically or narrower, which stretches in the amplitude. Yeah? Okay, and then we have a vertical displacement. Two up. What's our midline? What's the horizontal line that cuts this graph in half? Y equals 2. Did the range change? Our range is normally -1 to 1. Yeah. Did the period change? What's the only thing that changes our period? Horizontal stretch, did we get one? No. The domain doesn't change. Do our x-intercepts change? Yes. Actually, basically, anytime you get a transformation, except for a vertical stretch, it's basically going to move your horizontal, your x-intercept. And our y-intercept changes. So what's our max? How do we figure it out? D plus Yeah, d plus the amplitude, so it's going to be 2 plus 3, which is 5, which makes sense. I have a horizontal line at 2. I go up 3 more. I'm going to max out at 5. Then my minimum, I have a horizontal line at 2. I'm going to go down 3, so I'm going to get negative 1. So what does this graph look like? Y equals 2. And then the amplitude is half the distance, correct? So I'm going to go up 3, and I'm going to get to 5. Or I'm going to go down 3, and I'm going to get to negative 1. That's what you're doing. You're drawing a horizontal line at 2, and then you're going up 3 to get to 5, or down 3 to get to negative 1, right? Ultimately, that's what you're doing. So it's going to be negative 1 to 5. I'm just going to swap between interval and set. The next one, we have a midline at y equals negative 3. We have a vertical stretch by a factor of 2. Remember, we can't put BAFO on a test because only we know what it stands for. About the x-axis. And a vertical translation, or vertical displacement. Did I put vertical? Oh, good. Thank goodness I didn't. Vertical displacement. 3 down. So my mapping would be the same if I asked for mapping, right? It would be xy becomes x comma 2y minus 3. And what graph would we apply our mapping to in order to get this correct? What would the basic function be? Y equals cos x, yep. So. And what would the range be? Well, we have a midline at y equals negative 3. And then we're going to go up 2 to get to 1, and then down 2 to get to negative 5, right? So our max equals negative 3 plus 2, which is negative 1. And our min equals negative 3 minus 2, which is negative 5. So our range is y such that low to high. Negative 5 is less than or equal to y, less than or equal to negative 1, YER. What happens here? We have some X stuff going on. It's called the horizontal phase shift. So glad you like it. Horizontal phase shift. Pi over 2 to the what? To the right. Now, this is our C value, correct? If our C value is in radians, then our graph's in radians. Keep that in mind. So this graph would be in radians. The first few could have been in degrees too. That's your y values. Your degrees and radians are based on your x values, right? Your y values are like 1, 2, 3, 4, 5. Then your x-axis is what's in degrees or radians. So, is my amplitude affected? No, I have no vertical stretch. Is my range affected? No, my d is still 0, and my a is 1. When my d is 0, my a is 1, my range doesn't change. The period of my graph? Did it change? No, because I don't have a horizontal stretch. Horizontal stretches make it wider or narrower, which is the only thing that affects your period. The domain is XER no matter what. Do my x-intercepts change? Yes, because it moves my graph. Do my y-intercepts change? Yeah, because it shifts it over, right? What happens if I had this? What would you have to remember to do? Take out the 2. Told you the whole time this is going to happen. So it actually would be a horizontal phase shift 45 degrees to the right, not 90 to the right. Do you suppose 90 to the right will be an answer? Absolutely. Okay. Make sense? Clear as mud? Okay. This is where it gets a little harder. So I am going to use 1 first. You might want to pull out a separate sheet of paper so you can put the equations on. Excuse me. You won't have enough room. So when we come up with equations, remember that sine and cos graphs are just a horizontal phase shift away from being each other. Yeah? That's all they are. So sine and cos graphs are a horizontal phase shift away from being each other. So let's think about this. We are going to actually come up with all the information off of this graph first. And we'll do the sine ones first, and tomorrow we'll do cos. So amplitude. How do we get the amplitude off of a graph? How do we get the amplitude off a graph? Max minus min divided by 2. Or half the distance from min to max. So you could literally count it, right? So this one's from -1 to 1, which is a distance of 2. So what would my amplitude be? 1. So my A value is going to be plus or minus 1. Why would I say it could be positive or -1? Yeah. You can write it on a separate sheet. I just have to keep it on here because I'm going to start writing over a different graph, but I can erase it. You don't have that option, so you might want to write it on a separate sheet. Okay. So A is going to be positive or -1 because the amplitude is always positive, correct? But does the A value have to always be positive? No, it could be a reflection in the x-axis or not. So just because we get an amplitude equal to 1, why do I have just 1 dash? I'm not sure. It looks like -1. Amplitude equal to 1 doesn't mean that our A value has to be positive, right? What else can we take off of the graph? The period. What's the definition of the period of a graph? How long it takes to repeat itself. So it could be from a max to a max. It could be from a min to a min. It could be from a certain distance past a max, past a min, back to that same height, right? It's just how long it takes to repeat itself. I'm going to go from a max to a max just because the max is on the y-axis. So that's why I'm doing this. I could start from this x-intercept and go to the next one, but that would be harder because of the ticks, right? So from a max to a max, what's this graph? The period of it? 2 pi. What can I get from my equation from the period? Remember, I have variables a, b, c, and d. We agree? What does the period give me? What one of the variables? It gives me the horizontal stretch, which is my b value. Yes? So remember that the period equals 2 pi divided by b. And in this case, I said 2 pi because my horizontal axis is in pi's. It's in radians, right? So p equals 2 pi over b, or b equals 2 pi over p. So if I need the period from a graph, I would use the first one. But right now, I need b value from the graph, right? So I'm going to use this one. So what's my b then? My b is 2 pi divided by the period, which happens to be 2 pi. So my b is 1. Why would it be 1? It hasn't changed. Yeah. Yeah. It hasn't changed. My horizontal, or my period's 2 pi on a normal equation, right? On the basic equation, it's still 2 pi. That means it hasn't stretched. So that makes sense. It's a 1. My d value is also really easy to get. What's the d value stand for? that midline, that middle line that cuts the graph in half. So if I count my amplitude up and my amplitude down, they should meet at the midline. We agree? So my amplitude is 1. So if I count 1 up and 1 down, where do they meet at? Y equals what? We agree? So my D value is 0. My C is where people get a little sad. Okay, we're going to do coses first, actually, because coses are easier. Type into your calculator y equals cos x. So in our y equals, we have cos x. We agree? I'm going to go mode radian, and then I'm going to go zoom trig, because I have to pick my mode first. Okay, so we have that. We agree? That's the basic cos graph. Positive cos graph. So this is what we need to note. Our maximum on the positive cos graph is on the y-axis. So if there is no C value, my maximum will, for positive cos, because this is where A is positive, right? My maximum will be on the y-axis. We agree? If my maximum is moved anywhere off of the y-axis, there's a C value. There's a horizontal phase shift. Okay? So let's look at ours. Where is my maximum? It's on the y-axis. So for A is greater than 0, my C value equals 0. So when my A value, when my leading coefficient is positive, my C is actually 0. So when I go to write out the equation, I would get y equals positive 1 cos 1 x minus 0 plus 0. Do I need the zeros really? Or the ones? This is actually the cos x graph, if you didn't notice it. So when we use positive A, this is the cos x graph. All right? However, when A is less than 0, so I have A equal to negative 1 in this case, my graph switches. What does that negative A cause the graph to do? Reflect in the x-axis. So I'm going to go back to my calculator. Phase shift. So if I go negative, I can insert negative cos x. Oh, I put subtraction. Good one. Negative cos x. Now instead of my y-intercept being the maximum, what's my y-intercept? The minimum. So on a basic negative cos x graph, I have my minimum on the y-intercept. If my minimum is not on the y-axis, there's a phase shift. Okay? Where's my minimum? Here or here. So it either moved, because remember it was on the y, so it either moved pi to the right, or what option could they give us? Pi left. Both of those could be correct options. Would they put both on? No, because then both would be correct. You can't have two correct answers in a multiple choice. How would I know what? One of them would be x plus pi, one would be x minus pi. So we could have y equals negative cos 1, technically, x minus pi plus 0. We don't need the 0 or the 1. Or we could have y equals negative cos 1 x plus pi plus 0. what they'll say is they'll ask for the equation in the form y equals a cos b x plus c plus d when a is less than 0 or when a is greater than 0. So they will force you to either have a negative a or a positive a by just saying a is less than 0 or a is greater than 0. If they say a is less than 0, you look for where the minimum is away from the y-axis. If they say x is or a is greater than 0, you'll look where the maximum is away from the y-axis to get your c value. Does that make sense? So your C value is completely for cos based on where your maximum or minimum is and depending on what A value. So we'll look at one where it's shifted, I think the next page. I think I have some. Yeah. So let's look at this one, 8. So I need to get my amplitude to get my A. What's my amplitude of this equation? Max, which is 3, minus min, which is -1 divided by 2, which is 4 divided by 2, which is 2, which makes sense because from -1 to 3 is a distance of 4, and half of that is 2. Amplitude's half the distance. We agree? From the amplitude, so my A value is either plus or minus 2. The next thing that's really easy to find once you have the amplitude is your D value, your midline. Because you literally count down your amplitude, count up your amplitude, where they meet is your midline. So if I count down to, and I count up to, where do they meet at? Y equals 1. So my D value is equal to 1. How do I get my B value? Two pi divided by the period whenever it's off of an equation, right? Or off of a graph, sorry. So what's the period of this graph? How long does it take to repeat itself? I'm going to go from min to min just because my min's on the y-axis. So min to min is 2 pi. So my B value is 1 because it didn't stretch it, right? And then my C value is based on whether A is positive or not. So I'm going to go, the equation is y equals a sine, oh, not sine, cos, doing sine tomorrow, sine's a little harder, cos B x minus C plus D. That's the equation. We just need to fill it in. So we're going to have 2. We're going to have y equals positive 2 cos 1 x something plus 1. And then we're going to have y equals negative 2 cos 1 x something plus 1. And how we know which one we need to find? They would say in the equation, a is greater than 0 or a is less than 0. If a was greater than 0, we'd have to do this equation. If a was less than 0, we'd have to do the bottom equation. How do we get our C? Yeah, you count how far away. For this one, the minimum is, minimum from y-axis. And for greater than 0, you look for how far the maximum is from the y-axis. This one's done. I could take away that gap that's in there. Why is it done? Because the minimum is on the y-axis. It didn't move at all. This one, I could put negative pi or plus pi. Is it always pi? Is that, can I 2 examples and it's pi? It must always be pi for life. Yeah. Only because it's symmetrical. If I shifted it, it wouldn't be. So this would be x minus pi, or I could put x plus pi. How would you know which one's correct? Well, if they gave it to you in this equation, x minus c, then you would put pi. Does that make sense? You look for where, the c is the hardest thing to find. You literally just look for how far away the max is from it. The y-axis are how far away the min is from it. So your questions to work on are these. We're doing the sine tomorrow, and then we're quickly doing tan graphs because they're very simplistic. They're not the same though. So page 250. Remember, these two equations that I just made, I could also make two sine equations for that exact same graph, right? It would just, the c values would be different. But the a, the b, and the d is all the same whether you're finding sine or cos. It's just the c value that changes. Because a sine graph is just a horizontal phase shift away from a cos graph. If you just shove them over, it would be on the same graph. So numbers 1 to 3, pick 2. If I were you, I don't mean pick 2 numbers, I mean pick 2 letters. I would always do the last 2 if it were me, like E and F or something like that, because those are the harder ones. Those are the ones you're going to have to take. Remember, take the B value out. Don't do the easy ones. I see you. Because you were smirking. You were smirking, Larkin.